Welcome to today's class. In this class, we will see Zeroth Law of thermodynamics. Okay? In this class, we will see Zeroth Law of thermodynamics. Zeroth Law of thermodynamics. Actually, in many sciences, the laws are start from first law, but here zeroth law. Actually, first and second laws are postulated first. After that, they postulated the zeroth law. Okay, that is the reason. After 1 and 2, they cannot give this temperature thought, but they are giving 0. Okay, zeroth law. What is the zeroth law? States when two bodies are thermally equilibrium with third body, then these two bodies are thermally equilibrium with each other. Okay, once again I repeat the definition. Please note all the students. When two bodies thermally equilibrium with third body, then these two bodies are thermally equilibrium with each other. Okay? Now, consider this is body A and this is body B. Right? And these two bodies are separated with an adiabatic wall. That means there is no heat transitions in between these A and B. This separation is we can call adiabatic wall. Adiabatic wall. Okay, there is no transfer. A has its own temperature and B has its own temperature. Now consider body C. Okay, let it be body C is like this. This is C body, and in between A and C, and between B and C, perfect heat transfer. There is no restriction or hurdle in between these two. Okay, that means we place a diabatic wall. Okay, perfect heat transfer it is there. And when it comes to thermal equilibrium, A and C both are in thermal equilibrium condition. And B and C, these both are thermal equilibrium condition. Then we can say A and B also in thermal equilibrium. Okay, also in thermal equilibrium. That means when two bodies are thermal equilibrium with third body, then these two are thermally equilibrium with each other. Okay, this is given in the Zeroth Law of thermodynamics. That means the third body we can consider as temperature gauge. Okay, thermometer. Temperature gauge, that is thermometer. Right. And A hot bath. Okay, and B also a hot bath. Now thermometer is placed in a hot bath. Okay, and some temperature is noted. Okay, when the temperature will note, the thermometer and hot bath both are in equilibrium, thermal equilibrium condition, that will give a constant. Now, the same thermometer, if it is placed in B, it will show some temperature and it is in the thermal equilibrium. Okay, the temperature shown by A and the thermometer and the temperature shown to thermometer when it is dipped in B, if these two are equal, then A and B are in thermal equilibrium condition. Okay? A నుంచి B కానీ B నుంచి A కానీ ఎటువంటి ఫ్లో ఉండదు, థర్మల్ ఈక్విలిబ్రియం కండిషన్లో ఉంటుంది. ఓకే, దెన్ when these are two are thermal equilibrium condition and there is no heat transfer from one body to another body, one property must be equal. What is that property? That property called as temperature. The property is called as temperature. Okay, therefore the temperature is the property given by the Zeroth Law of thermodynamics. That we need to remember. Many times it is asked in examinations as well as competitive interviews. Right? If there is no flow of heat energy from one body to another body, a property is equal for both the bodies. That property is nothing but temperature. Okay, that is the definition we can note for the temperature. Okay, and one more thing, heat is a form of energy, but temperature is degree of heat. Okay, degree of heat, temperature. Right? We need to note. Right. Now, to measure the temperature, different thermometers, depending on thermometric property, we can devise. Okay, depending on thermometric property of a meter, we can devise different types of thermometers. This is the common thermometer, which we can see in our vicinity. This is the bulb portion and it is having mercury, and the cross section of the cylindrical tube, that is constant. Okay, here not external, internally a small capillary tube that will be there. Okay, its cross section is throughout the length is same. Right. Now, when we put this mercury bulb into a body, okay, over a body, then the mercury will expand. Okay, that means expansion of mercury is the thermometric property of the respective mercury. Okay, and that expansion is volumetric expansion, but we are keeping area as constant. Therefore, only linear expansion we can observe. Right? Therefore, change of length in the cylindrical column we can use as thermometric property, and we can devise a thermometer. Okay, mercury thermometer. Constant pressure thermometer. Constant pressure thermometer. Okay, what is the thermometric property? Use thermometric property. Thermometric property is delta V, change in volume. Okay, and if you devise constant volume thermometer, constant volume thermometer, then thermometric property is change in pressure. Okay, and if you devise resistance, electrical resistance thermometer, if you use, okay, then change in property due to heat energy is delta R. Okay, change in resistance. Right? If you go for thermocouple, okay, if you go for thermocouples, okay, if you go for thermocouple, then thermocouple based thermometers, okay, when heat energy is received, a potential is created. and the potential difference is caused for generation of EMF. Okay, therefore generated EMF, it is directly proportional to the respect to heat energy or temperature. When temperature is more, generated EMF will be more. Temperature is less, generated EMF will be less. Okay, that means that thermometric property is generated EMF. That is the thermometric property. Next one is, if you consider mercury thermometer, right? In the change in length, okay, we will use. Okay, based on this, we can devise these 5 types of thermometers, right? Okay.